So in section 9.1, we're going to talk about inverse functions. And this is hitting the SLO number 1. The module learning outcomes we'll be working on apply the concepts related to inverse functions. Determine whether two functions are one-to-one. Determine whether two functions are inverse functions. And graph the inverses of a function. So we're going to first start with a definition. A function is a correspondence such that each member in the domain, x value, corresponds exactly one member in the range, y value. We saw that back in chapter 5. So just kind of reminding you that when I plug in a value of x, I should only gain one answer for y. If I get more than one answer for y for a particular value of x, then it's not a function. A function f is one-to-one if each x value corresponds exactly one y value and each y value corresponds exactly to one x values. In other words, f is one-to-one and x1 and x2 are any values from the domain of f. If x1 does not equal x2, that implies f of x1 does not equal f of x2. So not only do each of my x values can only produce one y value when it's one-to-one, but also if I'm given one y value, it can only come from one x value. So for example, if I look at the x squared function, that would not be one-to-one because if I look at 9, I have two ways I can get 9. I can get it from x equals 3 or x equals negative 3. So that would not be one-to-one. Still a function, but not one-to-one. So let's look at some examples. So example of a function would be the price y in dollars of an external hard drive is a function of the storage side x in terabytes. In other words, the price of the drive depends on the size of the drive. So we have a 4 terabyte drive equals $179.99. 8 terabyte hard drive $289.99. 12 terabyte $419.99, and 16 terabyte hard drive $575.99. And we can express our function this way using points. The function above relating the price as a function of storage size is one-to-one, since each side has a different price and each price corresponds to a different size. So here's the idea. If I give you a y value, you should be able to tell me where it came from. Should be one. So in other words, when I say that I spent $419.99 on a hard drive, you know it's the 12 terabyte hard drive. If I tell you that I spent $179.99, then you know I bought the 4 terabyte hard drive. Now let's consider a function relating the state of to the number of electoral college votes of the top 6 states. We have California 55, Texas 38, New York 29, Florida 29, Illinois 20, Pennsylvania 20. You want to note that this is a function, but it is not a one-to-one since there's one y value, 20, that corresponds to both Illinois and Pennsylvania. There's also a y value of 29 that's coming from 2 different states. So if I told you that this state has 29 electoral college votes, you would not be able to tell me which one it was. It could either be New York or Florida. So it's not one-to-one. I can't determine specifically which state it is. And remember when we were doing functions, we had the vertical line test? Well, if we have a function, we have something called the horizontal line test that shows it's one-to-one. If any horizontal line intersects the graph of a function in more than one point, then the function is not one-to-one. Now, to show a function is one-to-one algebraically, you would have to set f of a equal to f of b and solve it. And if you get a equals b, then the function's one-to-one. So let's go ahead and tap into our workbook. And we want to go through and identify one-to-one functions. So again, just a reminder what a one-to-one function is. So we gotta make sure, like when we got points like this, gotta make sure each x value is distinct. So you have to make sure it is a function first of all, and then we also have to make sure that it's one-to-one. Each y value is distinct. So if I take a look at this first one, and we have 2, 1, 4, 2, 7, 3, and -2, 1. So first, looking at the x values, we can determine it's a function. But it's not one-to-one because notice I've got a y value 1 coming from a 2, and I have a y value of 1 coming from a -2. So this is a function, but it's not one-to-one. All right, let's take a look at this next one. So 8, 5, 4, -5. So yeah, this is a function. And then we got to check to see it's one-to-one. We got 1, 3, 8, and 9 for my y values. They're all different, so it is one-to-one. All right, let's try number 2a. So here they gave us a table. So each x value is different, so it is a function. But notice here, I have a y value of a that's coming from 2 different x values. So this is not one-to-one. Looking at b, it is a function. Each y value is coming from a different x value, so it is one-to-one. And remember, a function f of x is one-to-one if no horizontal line intersects the graph in more than one place. So like my x cubed function, that would be one-to-one. Whereas we talked about earlier that my squared function is not one-to-one. I can take a horizontal right here, horizontal line, and it's going to hit 2 points on the graph. So we're going to be looking at the graph, and the question is, can I find a horizontal line that hits more than 1 point? For 3, the answer would be no. So this is one-to-one. For number 4, yep, if I draw a horizontal line right there, I hit a bunch of points. So this would not be one-to-one. And then this would be one-to-one. Because any horizontal line here is going to hit at most 1 point. And then for 5 and 6, we want to use the definition of one-to-one function to determine whether the function is one-to-one. In other words, we want to show that if f of a equals f of b, then a equals b. And for this one, let's just kind of think about the picture here for a second. This is going to be a linear equation. Y-intercept 2, slope of 3. So it's going to look something like that. And so clearly, looking at the graph, it's one-to-one, because any horizontal line passes through at most one point. Whereas f of x equals 3x squared, it's just kind of a skinny parabola. So this should not be one-to-one. Now we have to show it algebraically. So what I'm going to do is I'm going to set f of a equal to f of b. F of a, if I plug in there, is going to be 3a plus 2. F of b will be 3b plus 2. Now I'm going to go through and solve for a. So I'll subtract 2 from both sides. That'll give us 3a equals 3b. And now I'm going to divide both sides by 3. Gives me a equals b. And we just proved that if we start with f of a equals f of b, we showed that a equals b. Let's see how that works in number 7. So again, I want to show that f of a equals f of b implies a equals b. And we'll see this won't work for this one. So f of a is 3a squared. F of b is 3b squared. And again, I'm thinking I'm solving for a, so I'm going to divide both sides by 3. And then I need to use the square root property. And when I do that, that gives me a equals plus or minus the square root of b squared, which gives me a equals plus or minus b. So here I cannot show that a equals b. So this is why this is not one-to-one. So number 6 was one-to-one. Number 7 is not one-to-one.